So we are going to move forward in Unit 4, and we're going to be looking at graphical properties of functions, okay? And what we're really going to focus on here is just how we can use this idea of the rate of change or slope on actual functions that are not straight lines by focusing in on just an interval, okay? So the average rate of change, anytime that you see that, you should be thinking slope, okay? So if we're looking for a function on a given interval, what we're going to do is we're going to identify 2 points on the given interval, okay? And then we're just going to calculate the slope. Okay, so the 2 points that we find on our given interval, we're used to seeing that the slope is like x1, y1, x2, y2. Because we're specifically talking about functions here, you might see them as x, f of x, x2, f of x2. Okay, something like that. So your y values could be listed as f of x values. Okay, so up here we would use our f of x values. But it's the same concept. We're just identifying 2 points that we can use to calculate our slope. Okay, so let's go ahead and look at an example. Down here it says, find the average rate of change for each of the following. And we're given a graph of f of x, and that's what's shown below. Okay, and we want to find the average rate of change for the function on the interval 4, 8. So when they give us this interval, okay, these are x values. This is saying we want to find the rate of change from the x value 4 over to the x value 8. Okay, so those are the points that I want to be able to find. I want an x1, y1 point and an x2, y2 point that I can use to calculate the slope. And we know we're looking at our x's from 4 to 8, so those are the 2 x values I want to use. I want to use the x value 4 and the x value 8. So I just need to find their corresponding f of x values or their corresponding y values, okay? So when I go to where x is 4, which is here, if I trace it up until I hit my graph, that's going to hit at the y value or the f of x value 50. So this point would be 4, 50, okay? Then I want to do the same thing with my second x value, which is at 8. I trace it up till it hits the point on my graph, which is at a positive 10. Okay, so that point would be the point 8, 10. So now that we have our 2 points, this is no different than calculating slope like we have in the past, right? So we're just going to calculate, remember our slope formula is y2 minus y1 over x2 minus x1. So I'm just plugging in my values, okay? So my second y value is 10 minus my first y value, which is 50, divided by my second x value, which is 8, minus my first x value, which is 4. And then we just simplify. So 10 minus 50 gives me negative 40. 8 minus 4 gives me 4. And negative 40 over 4 reduces to negative 10, which means that my slope or my rate of change for this function on that interval is negative 10. Okay? Not too bad, right? Just finding slope. We're just getting our points maybe from a different perspective or a set interval versus an entire line. Okay? Let's look at another one. Let's look at this one. It says, given the table of values below, find the average rate of change for the function f of x on the interval 3 to 7. Okay, so again, average rate of change, we should be thinking slope anytime we see that. And it's giving us a set interval from 3 to 7. Now remember, this is our domain. Okay, these are domain values or x values. So we want from the x value 3 over to the x value 7. So if I look at my points, I want to focus on this x value 3 and this x value 7. So this is where I'm going to get my 2 points from. Okay, so my x1, y1 point is going to be 3, 54. And then my second point, or my x2, y2 point, is going to be 7, 114. Okay, and once I have those 2 points, now I can calculate my slope. So I just plug in my slope formula, which is y2 minus y1 divided by x2 minus x1, and I plug in my values. So my second y value is 114 minus my first y value, which is 54, and we're dividing that by my second x value, which is 7, minus my first x value, which is 3. Okay, so we just simplify. 114 minus 54 leaves me with 60, and 7 minus 3 leaves me with 4. And 60 divided by 4 is 15, which means that the rate of change, or the slope, of this function on this defined interval from 3 to 7 is 15. Okay? All right, let me look at one more, and then I'll have y'all try one. So on this next one, it says, find the average rate of change for the given function on the interval 0, 5. So again, remember, these are our domain values, and our domain values are our x's, right? So they're telling us we want to find that rate of change. So again, we're looking for slope from the x value of 0 over to the x value of 5. Now, we don't have a chart or a picture to get those values off of, so we're actually going to have to take those x values ourselves, plug them into the function to be able to find their y values and get an ordered pair. Okay, so let's first figure out h of x1. So we want to plug in our first x value into the function, and our first x value on this interval is 0. So we're basically calculating h of 0. So I'm going to plug a 0 into this function everywhere I see an x. So I get 0 cubed plus 2 times 0 squared minus 0 minus 1. Okay? And notice all these terms that have zeros are just going to become 0, right? 0 cubed is 0, 0 squared is 0, times 2 is still 0, minus 0 is still 0. So what I end up with is a negative 1. So what I have come up with is I had an x, right? An x that I plugged in, and now a y value, or an h of x value, that I'm getting out. So this corresponds to the ordered pair 0, negative 1, because I plugged in 0 and my function equaled negative 1. So this is my x1, y1 point. Now I need another one so I can calculate slope, right? So my second x that I'm going to pick is the ending x of this interval. So I need my x2 value to plug into my function, and my second x value that I'm going to plug into this function is the 5, because that's the end of this interval that I want to know the rate of change of. So when I plug in 5, I plug in 5 everywhere I see an x in this function. So I'm going to get 5 cubed plus 2 times 5 squared minus 5 minus 1. And then I just simplify. 5 cubed is 125 plus, here I do my exponent first, okay? So I have 2 times 25, and then I'm going to go ahead and combine my negative 5 and my negative 1 to get negative 6. So I need to simplify this multiplication that I still have here. So I have 125 plus 2 times 25 gives me 50 minus 6. So 125 plus 50 is 175 minus 6 gives me 169. Okay, so that gave me the output, or my y value, when I plugged in an x value of 5. So as an ordered pair, this gives me the point 5 that I plugged in, right, and 169 that I got out. So this is my x2, y2 point. Okay, so we had to do a little bit of extra work here. We had to plug in our x's to even figure out what our y's are. But now that we have those 2 points, now we just use those 2 points to identify our rate of change, our slope. Okay, so that was part 1. Now we want to find our slope. So we do y2 minus y1 over x2 minus x1 to figure out our rate of change. So my second y value here is 169 minus my first y value, which you can see is negative 1, all over my second x value, which is 5, minus my first x value, which is 0. So notice on top my double negatives become positive. So I end up with 170 over 5. And 170 divided by 5 gives me 36, which means that the slope of this function on the interval from 0 to 5 would be 36. Okay, not too bad. All right, so there is one on the top of page 17, okay, top of the next page, for y'all to try. So they're giving you the problem, they're telling you the interval, you identify the points and calculate the slope. Okay, whenever you're ready to check yourself, go ahead and unpause the video. All right, so the first thing we need to do is identify our two ordered pairs so that we can calculate slope, right? And we want this on the interval of 5 to 15. So 5 and 15 are going to be the two x values that we use. So you can see here at x equals 5, if I trace it up, I can see that my first y value is going to be at 60, right? Over here on my second x value of 15 that I chose because that's the end of this interval, if I trace it up till it hits my function, my second y value here is going to be 20. So I end up with a point 560 and 1520. And then once I have those two values, I'm just plugging them into my slope formula to calculate my rate of change, which in this case should come out to -4. Okay, hopefully not too bad. So I want to go ahead and move on and talk about finding intervals of increasing, decreasing, and also what we call our local extrema. Okay, so let's look at this one. So I want to talk about just a couple of things. First, increasing. When we talk about where a function is increasing or an increasing function or determine if it's increasing, what we're looking at is as our x's get bigger, are our y's also getting bigger? Okay, so in other words, as x's increase, y's also increase. Okay, so if I look at this picture, as my x's increase from left to right, I can see here that as these x's are getting bigger, -6 to -5 to -4, notice my y values are also getting bigger, right? Because at x equals -5 here, my y value would be here. And then as x goes to -4, then my y value is up here. So if I trace my finger along this this function, notice it's increasing, right? As I go from left to right, this is increasing up to this point, right? Then we want to look for decreasing. Decreasing is the same. Basically, as x's increase, okay, or as we look from left to right, if it's a decreasing function, then that means that our y values are decreasing, okay? So I'm just going to write here, as our x's increase, y's decrease, okay? All right. So the last thing, let's see, let me go ahead and let's just look at this function. So we can see if we trace this with our pencil or our finger, as we go from left to right, my pencil's going up, right? So this is increasing. And then at this point it changes and it turns into a decreasing function, right? And then at this point it changes again and it becomes an increasing function, okay? So I'm just going to go ahead and make some little marks here to kind of identify these intervals. Okay, so this whole interval here is going to be an increasing interval, right? And then it changes to a decreasing interval, and then it goes back to an increasing interval. Okay, so if I want to go ahead and identify these intervals, I'm going to use interval notation. So I'm going to go ahead and just say for both of these, we use interval notation. Okay, interval notation to describe the increasing and decreasing intervals. And we do it in terms of our x values or our domain values. Okay, so this first increasing interval, and I'm going to go ahead and just draw some arrows on here because I think it cut off when I printed it. So I want to know for this interval, what is my x value span? What is it increasing from what x value to what x value? Well, since this has an arrow, this is going to keep going back and back and back and back and back, right? So that means that, for example, for our picture here, it's going to start at negative infinity, right? And from negative infinity, it's going to increase across all these x values until it gets to this point, right? This is increasing up to this point. And notice this point, my x value is at -4. So it increases from negative infinity up to -4. And I'm not going to include -4 because that's a turning point, right? It's going from increasing to decreasing. So it can't be both increasing and decreasing at -4. So we're just not going to include those turning points, okay? Then I notice that it starts decreasing, right? So it's decreasing from this point, which has an x value of -4, over to this point, which has an x value of -2. So from -4 to -2 is where my function decreases. So for our example, we're decreasing from -4 to -2, right? And then it changes. Again, I'm not going to include -2 because that's a turning point, right? It changes from decreasing back to increasing. So starting at -2, now we're going to have another increasing interval that starts at -2 and is going to keep going as we go left, right? So as my x's keep getting bigger, this is going to keep going and going and going and increasing, right? So it's going to increase from -2 to infinity, to as far to the right as this function goes. Okay. All right, so a couple of things to mention. Increasing, decreasing. We're just tracing our finger, tracing with our pencil to see if our line's going up or if our line's going down. But we write those intervals in terms of the x's, right? Not the y's. So we have the interval from here, negative infinity to -4, -4 to 2, 2 to infinity. Okay, so those are the intervals that we're using to identify increasing, decreasing, increasing or decreasing. Okay, now we talked a little bit about these turning points, right? These turning points is where it changes from increasing to decreasing. And what happens is when it turns, it creates the top of a parabola, right? Or it creates the base of a parabola. So it's a really high point or a really low point, which we call a local maximum or minimum, okay? And these are our local extrema. Okay, meaning that in a localized area we have a really high point, or in a localized area we have a low point. Okay, so this is basically the y values for which the graph changes from increasing to decreasing, or vice versa. Okay, the y values for which the graph is changing from increasing or decreasing, right? So when we talk about our local extreme, our local max, or our local min, we're talking about the y values. What is that maximum y value at that point? What is that low y value at that point? Okay, so increasing, decreasing is in terms of the x. Maximum, minimum is in terms of the y. Okay, so for our example here, let's go ahead and put our example. We have a local maximum, right, at this point right here, because it's changing from increasing to decreasing. So that creates a maximum point, and the maximum y value at that point is 5. So this would be y equals 5. Okay. We also had another turning point here, which creates a local minimum, and that minimum value happens at y equals 1. Y equals 1. Okay. Does it kind of make sense? Maybe not too bad. Increasing, decreasing, trace from left to right, and list the intervals in terms of our x domain values. Okay. Local max and min are determined by those turning points, and we use the y values at those points. Okay. So I'm just going to put that special little note here because that's what everyone seems to forget, that increasing and decreasing intervals are always written, whoops, I'm coming off the page here, are always written in terms of x, okay? Always x values, always domain values when we're doing increasing and decreasing intervals, okay? Only the local max and min utilizes the y values, okay? All right, so on the back page, there is 2 for you to try, okay? So I want you to identify the intervals where it's either increasing or decreasing, and then also identify the local minimum, the local maximum, if there happens to be one, okay? Go ahead and pause the video, and when you're ready to check yourself, you can play again. All right, so number 1, notice this one starts off decreasing down to the point of x equals 1. So from negative infinity all the way over until I hit 1, this is decreasing. So I'm going to write that interval as negative infinity to 1. Then it changes at 1, right? And notice it's going to go to increasing. And it's going to increase from x equals 1 over to this point, which is x equals 5. So this is an increasing interval from 1 to 5. So notice for increasing, I listed 1 to 5. And then at 5, it turns again, right? Now it's going to be decreasing. And so it's decreasing from from 5 on out to as far out as this graph goes. And again, I don't have the little arrow, my bad, so you can draw that in. Okay, so that would be from 5 on out to infinity. This is going to be a decreasing interval. Okay, so I'm going to just put a comma and add on my decreasing interval from 5 to infinity. Okay, I had 2 turning points. This one is where it changed from decreasing to increasing, which created a minimum, and the minimum value at that point was 3. So I have a local minimum at y equals 3, and then I have another turning point where we went from increasing to decreasing, which creates a local maximum, and the maximum y value at that point is 6. So I have a local max at y equals 6. Okay, let's look at the second one. So for number 2, same thing. Notice this function starts off increasing. So from negative infinity, wherever this guy goes way down and starts from negative infinity up to this point, it's increasing. And that point is at negative 1. So I have an increasing interval from negative infinity to negative 1. Then at negative 1, it changes, right? It starts falling. So from negative 1 until it gets done falling over here at this point, it's decreasing. So that would be from the x value of negative 1 over to the x value positive 1. Okay, so from negative 1 to 1, we have a decreasing function. And then it turns and starts increasing again. So then from 1 to as far out as this function goes, it will be increasing. So that will be the interval 1 to infinity. Again, we're using parentheses on all of our turning points. And then this also creates a local minimum and a local maximum. Okay, our first one went from increasing to decreasing, which creates a maximum value at y equals 4. So we have a local max at y equals 4. And then when we changed from decreasing to increasing at 1, at x equals 1, it created a local minimum value. And that minimum value is y equals negative 1, which we have written here. Okay? All right. So that is the conclusion of that assignment section, which is the graphical properties of functions. So you should now be able to complete this assignment listed on your Knewton assignments. Okay? If you have any questions, please let me know.